Hello everyone. Today let's solve the problem number this one. Let's solve the problem friends or not. So this was asked on Codeforces VK Cup 2012. So qualifications round 2, right? Qualification round 2, sorry. Yeah. So let's basically solve this problem. This one friends or not. So you can just go through the question. It is easier to understand. I'll just summarize the question so that it will be very simple to understand and it will be easier for us to solve the problem as well, right? So what the question states here, just give me a second. What the question states here, we are given a log of messages. We are given a log of messages. So just keep this in mind. We are given a log of messages and a time difference d and a time difference d, right? So we are given a log of messages and a time difference d. So users a and b become friends if a sent a message to b at time 1. If users become friends if a and b becomes friend if a sends message to b at time 1. At time 1 nothing but t1 here. If a sent a message to b at time t1 and b replied to a, and also b replied to a such that 0 less than t2 minus t1. So this condition is very important. So 0 less than means it shouldn't go below 0. It has to be basically t2 minus t1 has to be less than or equal to d. Has to be less than or equal to d. So this is the condition. So we are given a log of messages and a time difference d, right? So users a and b become friends if a sent a message at time t2, if a sent a message to b at time t1, sorry, at time t1, and b replied to a at time 2, b replied to a at time t2 such that this condition. So t2 minus t1 shouldn't go less than 0, and also it has to be less than or equal to d, and also it has to be less than or equal to d. D is nothing but here we know this one, the time difference. D is nothing but the time difference here. This is nothing but d here. D is nothing but the time difference. Again, one more last time I'll just read out the question loud. Just listen to this. We are given a log of messages and a time difference d and a time difference d. Users a and b become friends if a sent a message, sorry, to b at time t1 and b replied to a at time t2 such that t2 minus t1 shouldn't go less than 0, and also it should be less than or equal to d. So that's the condition basically, right? It's very simple question, right? So I'll just remove this one. Let's come to the this one. What do we call input part or the examples part here? So we have been given four inputs here. We have been given four inputs here. You can clearly see, right? So Vesya here sends the message to Petya, right? And they are having that this one. What do we call time difference d? They are having one. So same thing goes with Petya and Vasya as well. Same thing goes with Anya and Ivan as well. Ivan, Anya, right? So here this is nothing but A sending message to B and B replying to A, right? A sending message to B and B replying. This is nothing but here this one is T1, one what they have given in the first line. This is t1, and this 2 we have to go with t2 2 minus t1. T2 we have been given 2 here, right? T1 we have been given 1, right? So this one has to be 2 minus 1, we'll get 1, which is less than or equal to d. So d we have been given here 1. So d is 4 1. The second part is d here, this one is nothing but d. So here we have been given 1, here we have been given this one, what do we call d1000 here in this case, right? So the second part is nothing but the d here. So just don't get confused here, sorry, not this one, this is output. Sorry, I got confused. So this one d we have been given 1000 here, so the output that we need to get here is 0. Same goes with the example 3 as well. So just give me a second. They have given input 3 or the example 3 or what? No, only two examples, right? So here this one, this is nothing but d1. This 4 is nothing but the number of input. So we have here Vasya Petya. This is nothing, this 1 is nothing but t1. This 1 is nothing but T1 and this 2 is nothing but the T2. As we have discussed, this Vasya Petya means A sending this one. A is Vasya, B is Petya, right? So here Vasya is sending the Vasya has sent a message to Petya at time T1, nothing but 1, and Petya is replying to Vasya at time T2, right? So accordingly with the question, what we need to do, we have to check whether T2 minus T1 shouldn't go less than 0, and also it has to be less than or equal to D. Let's discuss this one during the approach so we understand this one clearly along with the whatever approach we consider, right? So you'll understand this one crystal clear. I am pretty much clear. Means I can bet on it that you'll understand these things very clearly, right? So the output that we need to get here is 1, 1 and Petya Vasya. And the second input goes like this as well. So here this is nothing but here this one. What do we call? This is nothing but T1. I mean, sorry, this is nothing but D. 1000 is nothing but D here in this case. This is nothing but one input we have here. One input we have. So here we have A sends a message to B at 0, this thing. What do we call? T1. Right? A sends a message at this one 0 T1. We have not been given T2 at all. So here in this case, the output that we need to get here is 0 itself. Right? So this is fine, I think. Right? So I hope the question part is completely clear along with the examples they have given us wonderful examples, right? Just for the sake of understanding, right? So now let's do one thing. Let's discuss the approach followed by the edge cases, and then let's write the code finally, right? So let's discuss the approach followed by the complexity, sorry, and then let's write the code. First, as usual, let's discuss the approach. So here we have considered the same first example. I have considered the same first example that they have given in the question, right? So we have considered the same first example. Here, this is nothing but the 4 is nothing but inputs, number of inputs. So here 1 is nothing but D. D here, 1 is D, nothing but the time difference, right? So here A is sending the message, nothing but to B. A has sent a message to B. Here Vasya has sent the message to Petya at the time T1. So this is T1 and Petya has replied to Vasya at time T2. Nothing but 2 here in this case. T2 is 2. So same goes with Anya and Ivan as well, right? So Anya has sent a message to Ivan at time T1, nothing but T1 is 2, and Ivan has sent a message to Anya at time T2. So this is nothing but T1 and T2. I hope this part is completely clear, man. This is fine. So the output that we need to get here is 1 Petya and Vasya. So 1 Petya and Vasya, because what we need to determine here is um, we have to return all the unique friend pairs from the log. We have to return all the unique friend pairs from the log, message log, right? We have been given the log message logs, right? So we have to return all the unique pairs of the friends from such a log, right? So this is fine. What we need to do here, we have to get the output 1 Petya and Vasya. So we have the idea on input output as well along with the question, right? Let's move on with the step by step explanation. I have considered the same first example, right? So here first what we will do, we will check if the message pair I comma j where I is less than or equal to j, I is less than or equal to j, right? So 1 is less than or equal to 2, no, right? So here if from I is equal to j and 2 of I is equal to from of j, and time of j minus time of I belongs to 0 comma d, belongs to 0 comma d. So this is nothing but belongs to symbol. This comes from the set theory. If you would have done the math, you would have known, right? So this is nothing but the belongs to. So here time of j minus time of I belongs to 0 comma d. So we have to store them as a friend pair in the lexicographical order. This part is very important, man. Just keep this in mind, don't forget this one. So we have to store them as a friend pair in the lexicographical order. Just for the sake of example, I have shown this one AB or BA. We will be storing this one in the hash set to avoid the duplicates. This is nothing but the lexicographical order, right? So we are storing them as a friend pair in the lexicographical order. So basically, I just wanted to tell you one thing. We will be going with a backtracking approach to solve this problem. As the constraint is not very tight, we'll be going with a backtrack. Backtrack suits well for this particular problem, right? As the constraint is not very tight, so we will be going with the backtracking for this particular problem. right? So just keep this in mind. We will store them as a friend pair in lexicographical order, nothing but a comma b or b comma a in hash set, just to avoid the, we can just make use of it hash set as well too, just to avoid the duplicates, or we can just go with pure backtracking as well, right? So we will be making use of the backtracking. Basically backtracking scans all the indices recursively. So backtracking uses recursion itself, we know this one, right? By this time we have to know that backtracking uses the recursion, right? Backtracking scans all the indices recursively, checking all such valid pairs, checking all such valid pairs, checking all such valid pairs. Backtracking scans all the indices recursively, checking all such valid pairs. This is fine. From the example, let's consider the first example here. Let's consider the first example here, right? Let's consider the first example here. So here, uh, Vasya is sending or has sent a message to Petya at time t1. We know this one. And Petya has replied to Vasya at time t2. Time t equals 2. At time t equals 2. This one is t1 and this one is t2. Right. So now, accordingly with the question, we have to go with the T2 minus T1 and check whether this is less than or equal to D or not. D we have been given 1, right? So we have been given input 4, 1, and then Vasya Petya, then Anya and Ivan, right? So here Vasya sent a message to Petya at T1 1 and Petya has sent a reply to Vasya at T2 2, right? So this one will be T2 minus T1, nothing but 2 minus 1, which is 1. We are checking whether 1 is less than or equal to D, nothing but 1 is less than or equal to 1. Yes, 1 is equivalent to 1, right? So 1 is equal to 1 basically, right? So now this is a friend, so we call this pair as a friend, this one, right? So we can consider this one friendship pair, right? Next, let's go with the Anya and Ivan. Let's go with the Anya and Ivan, right? So here in this case we have this one T1, we have 4, and T2 we have sorry, T1 we have 2, T2 we have 4. From the example, man, just don't get confused. Yeah, see here, this is nothing but T1, this is nothing but T2. Anya and Ivan, we are considering this pair. We are considering Anya and Ivan. First, we considered Vasya and Petya. Right now, Anya has sent a message to Ivan at time t1 2, and Ivan has sent a message to Anya at time t2 4. Right. So this we are considering. T1 is nothing but 2 here. T2 is nothing but 4 here. Now we have to consider T2 minus T1 is less than or equal to D. So 4 minus 2 is nothing but 2, and D we have been given 1. 2 is less than or equal to 1. No. 2 is greater than 1. 2 is not 2 is not less than 1, and also 2 is not equal to 1, right? So 2 is obviously greater than 1. This fails miserably. They are not friends. This friendship pair is not considered. Basically, Anya and Divan friendship pair is not considered. Only Petya and Vasya, or only Vasya and Petya, this one is considered. Friendship pair is considered here, right? So now we have to display output as 1 1, and this one, what do we call? 1 Petya and Vasya, right? 1 Petya and Vasya. That's what we have got in the this one output as well. See here, just give me a second here. So the output is 1 Petya and Vasya, or you can just go with the 1 Vasya and Petya as well. The this one order doesn't matter here, right? 1, this one is Petya and Vasya. 1 Petya and Vasya is the output that we got, which is equivalent to the output that they have mentioned for the first example. First example, or first input put within the question, right? So the output that we got here is equivalent to the output that they have shown for the example 1 within the question. So our approach works absolutely correct in this case. Now let's move further, right? So let's move further. So let's quickly discuss the complexities, and then let's write the code. So let me come to this part here. So what would be the time complexity and the space complexity here? The time complexity would be big of n square. You could have asked the questions. Basically, we are making use of the backtracking, so it should be 2 to the power of something, right? So usually um, backtracking, whenever we make use of the backtracking, it should be 2 to the power of something exponential, right? So it has to go 2 to the power of something exponential. So why it is n square here in this case, right? So here what happens is, for each message I, for each message I, we are checking all other messages, nothing but j not equal to I. j not equal to I. We are checking whether j not equal to I. So overall time complexity would lead to big of n square, not 2 to the power of something, right? Not 2 to the power of something, right? Usually when we make use of the backtracking, it would go 2 to the power of something x or n, you would call, right? So it goes in the exponential, this thing, the time complexity I'm speaking of, whenever we make use of the backtracking. Here for each message I, we are checking all other messages whether it is whether j less than or equal to I. So overall time complexity would lead to big of n square here, right? So what would be the space complexity here? The space complexity would be big of n plus k, because you would have already guessed big of n just for storing the messages and big of k for storing the unique field pairs, unique friend pairs, sorry, not field. So here big of n for storing the messages. So this part, first part is big of n for storing the messages, and this one big of k, big of n plus k we have considered right here. So big of k will be for storing the unique friend pairs. We have to store the unique friends pairs, and we have to return it, right, finally in the form of output. That's what they have asked the question, right? That's what they have asked the question. The condition is we have to go with the t2 minus t1 less than or equal to d, and this value shouldn't go less than 0 as well, right, accordingly with the constraint. That's what they have given. That's what the question is. So big of n is for storing the messages, and big of k is for storing this one, unique friends pairs. Unique friends pairs, I'll just write fp here, unique friends pair, storing unique friends pairs here, right? I hope the complexities part is completely clear. I mean, I hope the time complexity and the space complexity is completely clear, right? I mean, the time complexity and the space complexity for the code that we'll be writing in the future would be big of n square and big of n plus k. Now as we are completely familiar with the this one, what do we call, complexities and the approach part, we are good to write the code. Let's start writing the code, right? Let's start writing the code. Now let's start writing the code, right? So here let me come. So we will be making use of the fast input and output, also utilities. So let's import the input output package as well as the utility package first. So I'll just go with here import java.io.star. So this is fine, and also let's import here uh, java.util.star. This is fine. uh, let's go with the class name main here. So I'll just go with class name main here. You can give any class name, so it doesn't matter. So I'll just go with the main, or friendship pairs you can call it as well. So here first we have to go with the message structure to hold sender, receiver as well as the timestamp. In the input we have sender, receiver as well as the timestamp, but Petya, Vasya, and then T1 and T2, right? So sender, receiver, and timestamp, right? So this one, let's consider the static class, this one static class, this one message, right? So within this class, so what we'll do, so this one will be string from and to, this one will be string from to, so this will be int time, this is fine. So this one will be message, so this will be string f comma, this one will be string t comma, this one will be int ti, this is fine. So here within this we are just going with the initialization part, right? So I'll just assign from to f 2 to this one t, and this is fine as well. And let's assign time to ti, let's assign time to ti, this is fine. I'll just come out of this one entirely, so let me leave the space here as well, man, so that this looks good. So the next part is, let's go with the, let's initialize this one n and d, n comma d, this is fine. So we have to go with the array of messages as well, array of messages as well. We have to store the messages somewhere, right? So we will be considering the array of messages here. This will be static message we have considered above this one, and the variable name I'll just give here logs, this is fine. So we went with the array of messages previously. Now let's we have to store the unique friend pairs as well, right? So let's go with here static hash set. So we have discussed this one already within the this one, what do you call, approach, right? So we'll be making use of the hash set to store the unique friend pairs, used to store the unique friend pairs. So this will be set of the type string. So this one will be friends. I'll just go with a variable name friends. So this one will be new hash set. So this is nothing but the syntax here. This is fine. New hash set. So now we will be going with the backtracking. I have said this one repeatedly that we'll be making use of the backtracking approach within the approach. Whatever we discussed in the approach, the same thing we are articulating in the form of code. The exact same thing we are articulating in the form of code here. Now we will be going with the backtracking, or we'll be going with the recursive backtracking to process the message logs. We have to process the message logs here. So we'll be going with the recursive backtracking here. So I'll just give here static void, this one will be backtrack. So this one will be backtrack. So I'll just give here int I. So within this method, so I'll just go with if I equals n, then we don't have to return anything, right? So this is base case. If all the messages are proceeded, so then we don't have to return anything. So here in this case, if I equals n, we just don't have to return anything. I'll just give return here. So let's go with the current message, nothing but here message. So here in this case, I'll just give m1. Let me assign this one to logs of I, iterated value of the logs. I hope this part is clear. Next, we are done with the initialization. Now let's go with the iteration part. So here this will be int j equals 0, j less than n. So this would be j plus plus, right? So here this would be j plus plus. So this is fine. So here within this we have to skip all the self comparison, right? So here if uh, I equals j, we are skipping all the this one self comparison. So for skipping, I will make use of the continue keyword here. I'll make use of the continue keyword here. This is fine. Next, we have to do the same thing. We have to do the same thing, or a bit different for the m2, right? So here we are going with the message m2, nothing but the reply. So if the Petya sends a message to Vasya, and Vasya has to reply to Petya as well, right? Accordingly with the question. So we have to go with the M2 as well. This one is nothing but let me assign to the logs of I as well. So next, here in this case, we have to check if M2 is reply to M1. We have to check this one whether M2 is a reply to M1, right? And this is nothing but we are checking to and from or swapped or not. We are checking whether to and from or swapped or not. Let's write the simple if condition for that. Let's write the simple if condition for that. We are just going with the backtracking, and we are just implementing the same thing that we have discussed in the approach. We are just articulating the same thing in the form of code that we discussed in the approach here. Let's write the very simple if condition now. So this one we have to go with the logs of j, not the logs of I. Sorry. Yeah, this one. We are going with a reply, right? So here we have to check if M2 is a reply to M1 now, right? So let's write the simple if condition as I've said. I'll just go with M1 dot from. So this one dot equals, this one will be M2 dot 2, and also let's consider M1 dot 2 dot equals, so this one will be m2 dot from. This is fine. So here within the int, let me go with int difference equals m2 dot time. This one has to be m2 dot time minus m1 dot time, right? So t2 minus t1 we are doing here, m1 dot time. So this is fine as this is fine. So the next step is we have to check for the valid reply, right? If the time difference in 0 comma d, in 0 comma d, this one we have third step in the approach, I guess, right? Third step in the approach, theoretical approach. So here let's write the simple if condition as well for this. If difference, if it is greater than 0, and if difference is less than or equal to d, then what we need to do, we have to store this in lexicographical order to avoid the duplicate pairs, right? So I'll just go with string a. If you remember the approach, implementing the or writing the solution is not this thing. not a big deal, right? So this one will be m1 dot from dot, let's make use of compare to here, right? Let's make use of compare to. So I'll just go with compare to here, compare to of m1 dot this one to m1 dot 2. So let's make use of the ternary operator here. Let's do one thing. If it is less than 0, it shouldn't go less than 0, right? So if it is less than 0, then what we will do? So let's give m1 dot from, let's append or concatenate, let's append here this one space, then m1 dot 2. What shall we do for m1 dot 2? I forgot here, man. So just give me a second here. So this one has to be m1 dot 2. I can write in this way, right? m1 dot 2. Let's append this one here, m1 dot from. This is fine. This is fine. So let's do one more thing here. So let's add this one to the set. We have to add the unique friend pairs to the set, right? So I'll just make use of the add operation, right? So this will be friends dot add of a, that the hash set provides. Basically hash set provides add operation, right? So I'll just go with friends dot add of a. This is fine. Let me come out of this one entirely, man. Let me come out of this one entirely. We are going with the recursive call to process the next message. Nothing but we are making use of the this one, right? Backtrack here. So I'll just go with here backtrack of I plus 1 for the next one. We are considering the same thing, right? So we are making a recursive call here to process the next message. We have to go with the next one as well. We are done with the what do we call when we are done with the Vasya and Petya, we have to move to Avan and Ivan, right? So I forgot the name. Avan and Ivan itself, right? So the next one basically. So we are making a recursive call here to process the next message here, right? So we are done with this part. Now what shall we do? Now what shall we do? Let's go with the main function or the main method here. So this one will be, let me give main here directly. This is fine. So let's make use of the throws input output exception. Let's make use of the throws input output exception. So now let's write the code within the main method. Let's write the code within the main method. So first one, this will be buffered reader br equals new buffered reader new input stream reader. So this one will be system dot in. So this one will be print writer. So print writer. So this one output. This one will be new print writer. So this one is system dot out. So this one will be system dot out. This is fine. Let's move on with the further steps here. So here we have the space between the elements. We have the space between the this one. After Petya we have space, after Vasya we have space, and after that space itself we have got the final timestamp, right? So we have to read in that way itself. So I'll just go with here string first. First I'll consider the variable name first here, buffered reader. So what happened here? What did I just give me a second. Array, this just give me a second here. So let's continue now. So this one will be br dot read line here, read line dot split. This is fine. Read line dot split. This is fine. The next thing is we have to go with the number of messages and we have to go with the max allowed reply time as well. So for going with the number of messages, we will go with integer dot percent here. This one will be first of 0. This is fine. And also here d equals, so again I'll just go with the integer, same thing, parse. This one will be percent of first of 1. This is fine. So we went with the number of messages. Also the first of one, this line, the line number 42 is nothing but we are going with the max allowed reply time, right? So we went with the number of messages as well as max allowed reply time. Now we have to create the message log array. right? So we have to create the message log array. I'll just go with the variable name logs here. So this will be new message of, and this will be new message of, and this is fine. So next step is we have to read and parse each message into the message object. Nothing but here in this case, for int I equals 0, this one will be I less than n, this will be I plus plus. So within the for loop, what we will be doing, so same thing, string, this one we have to rewrite, same thing we have to do here, same input we have here. So instead of first, I'll just consider p, any variable you can consider, I'll just consider p here. Pr read line split, this remains same here. Same thing goes with next, we have to go with the logs of I. So this remains same. This one will be iterated value of the logs equals new message of p, we have considered the variable, right? So here p of 0 comma p of 1 comma integer dot parseint here, integer of parseint, this one p of 2, p of 2, this is fine. I'll just come out of this one entirely. Now what we have to do, we have to start the processing from 0th index, right? We have to start the processing from 0th index, nothing but as we have made use of the backtrack, so here let's make use of the helper method backtrack here. Backtrack, we have to start from the 0th index, so I'll just give 0 here, this is fine. So the next step, we are left with the input output part. Mainly we are left with the input output part, so we have to output the total number of friend pairs. First line, if you observe the output here, see here, we have to output the total number of this one friend pairs, sorry, we have to output total number of friend pairs here. So I'll just go with out dot println. You can just go with the system out println or out dot println. As we are going with the print writer, you can just go with the println here. So this will be friends dot friends dot size. So size, I have to give the parenthesis. So we have successfully output total number of this one, total number of friend pairs. Now after doing that, we have to output each friend pair. We have to output each friend pair accordingly with the output that we got. We have to output the each friend pair, right here. This one, the only one friend pair for this one, for this input is Petya Vasya. Right. So next one, if we would have got Anya and Ivan as well, accordingly with the condition that they have given. So in the next line, we have to output this one, Anya and Ivan as well. Right. So here, so in this case, we have to output each friend pair in each line. So for that one, let's make use of the for loop here. This one, I'll just go with the string s of friends. So this one friends. So let's go with out dot, so this one println of is individual friend pairs that satisfy all the conditions that they have given in the question accordingly with the output, right? So finally we have to ensure the output is printed, means we have to flush the output, right? Either we can go with the out.flush or out.close. I'll just go with out.flush here. In this case, we are just flushing the output. We are just making sure that the output is printed here by flushing the output. This is fine. So we are done with the coding part. We are done with the coding part. Before what do we call, before checking the code with the different inputs, I just want to copy paste the signature starter template. Just give me a second here. So I'll just come here, let me paste it over here. You can just ignore this part. So let's focus on the logical part now. So this is fine, we are done with the code actually. Let me come here, let me copy the input. So we have to get the output 1 Petya and Vasya, right? Let's see whether this works or not. So yeah, we are getting the output 1 Petya Vasya, right? So this code works absolutely correct. So let me come to the second input here. Let me copy this one. We have to get the output 0. We have to get the output 0 here, right? So because here in this case, A has sent a message to B with the time T1 0, right? So here in this case, B has not replied to A at all. So B has not replied to A at all. Time 2 is not known, right? So here, so the output that we need to return here is 0, and because the time t1 itself is 0, d we have been given 1000, right? So here let's check the same thing with this input. We need to get the output 0. Yeah, we are getting the output 0. So the code works absolutely correct for the examples that they have given. Let's see. Let's see whether this works for all the test cases or not. Let me copy this one. Let me paste it over here. We have already selected A here. Let me hit the submit button. So let's wait for some time. I hope this works for all the test cases, man. Let's see. So yeah, you can clearly see here, right? Running on test 4, 6, 7. Let's wait for some time. So yeah, you can clearly see here, right? The code got accepted. Whatever the code we wrote works absolutely correct for all the test cases, right? So we just made use of the backtrack basically, to be frank. So this is pure backtracking, right? So this is pure backtracking. As the constraints are not that tight, we can go with the backtracking for this particular problem. It works absolutely great, right? Backtracking works absolutely great for this particular problem, right? I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.